Okay, welcome back again. We are on circular motion, whereby the question is saying a 1,500 kg car moving on a flat horizontal road negotiates a curve as shown in the figure 3.1. If the radius of the curve is 35 meters and the coefficient of static friction between the tires and dry pavement is 0.5. Find the maximum speed the car have and still make the turn successful. So there is a simple diagram here. This is the curve. My car is. I'm looking at this car on the upper position. Now, what force makes this car move on the curve nicely without getting out of the path? It has to be the static friction which is pointing towards the center of that curve. If you go on roundabouts, you'll find that it makes something which is in a circular way. The point where there is the circle, that's what I mean, the point where there is a center, that's where the radius is starting from. And that's where this force which is called static friction has to be pointing. Okay, so I'm looking at this vehicle on the upper view. I can be able to identify only a single force, which is friction force. The nature of this same force has to be called centripetal force, because all the forces that are making the object point towards the center, they are given an actual name as centripetal force. Let's try to look at this vehicle on a given point, like on the back view. I'm looking at it now from the back view. We understand to say the same centripetal force, which is friction force, static, points towards the center of the curve. Then we also have two forces that makes this one move without sinking into the ground or going upwards. What are those? We are going to have the weight of this car. We are going to have the normal force pointing in that given direction. To balance these forces, there is another force which is moving away from here, though this force which is making the object move away from the lane, it is called centrifugal force, which is also denoted like that. So always centrifugal force, centripetal force, they all have the same formula, which is what? Mass multiplied by v square over the radius. Of which, what type of friction force are we having at this instant of time? You'll find that we are going to have the static friction. So to make matters simple, just forget about this. We are going to say centripetal force is pointing on the center, and the nature of the same centripetal force is what? The friction force. Meaning that friction force has to be equal to the centripetal force. And also the normal force has to be equal to what? The weight force. Now, how do you calculate? Here they are trying to ask you about the velocity, the speed. The maximum speed the car is going to do what? Is going to have. I'm saying friction force, which is static, must be equal to the centripetal force. What formula do you use whenever you want to calculate for friction force? They are saying friction force has to be equal to coefficient of static friction, which is mu, multiplied by the normal force. If you get back to this, the object is not moving or is not sinking into the ground, or it is not moving upwards. Meaning that the two forces, the summation of forces in one, must always give us what we call a zero. So what we are going to understand is the normal force is going to be equal to the downward force, while these two forces are balanced. So I'll say normal has to be equal to the mass of the car multiplied by its acceleration due to gravity. If you get back to this, we are saying normal force is equal to that. Meaning that friction force, it can also be equal to coefficient of static friction multiplied by mass multiplied by the gravity. Why? Because the normal force is equal to the weight of the object, and that has to be the formula to use whenever you want to calculate for friction force. Getting back to this, we understand to say the formula for friction force here has to be static mass multiplied by the gravity. I will equate these two. If you come to this, you will find that this one, which is centripetal force, is given this formula, which is like this. Okay, now mass is constant. In short, the velocity of the car, whenever it is moving on the curve, it has to be independent of the mass, meaning that this mass and that mass will be cancelled. Why? Because this is the only object which is having a mass at this instant. So we are going to have mu static g, I'll say equal to v squared over the radius. You can multiply this by that. We're going to have mu r g, which is going to be equal to v squared. If you square root on both sides, you will find that the velocity the car is going to have as the root of mu static r g. So you plug in the value that will be given. Make sure that the radius is in what? Meters. Make sure that this one doesn't have units because it is a ratio between the normal force, the friction force and the normal force. Then this one has to be 9.8 meters a second square. So my velocity at this instant has to be root of this one. If I'm to get back to the question that's saying it's 0.5. 0.5 multiplied by what is this? This has to be the radius, which is 5. Multiplied by 9.8, like this. Then if we try to calculate, we try to punch this on the calculator, what answer are we going to get? 0.5 multiplied by 35 multiplied by 9.8. You square root the answer. We are getting the answer as this two. 0.5 multiplied by, is it 35? Radius 35 multiplied by, okay, let me do this. 0.5 multiplied by 35 multiplied by 9.8. Okay, so we're getting the 2.09, which is equivalent to 15.10 meters per second. This is supposed to be the speed a car had as it was moving on the curve.